All right, so how many of you are hungover right now? It's less than I thought, so you're doing pretty good already. Good job. All right, Sean told me to take it easy on everyone just in case, so today we're going to start with lambda calculus. All right, no, so like you said, I'm Matt Machuga. Um, this talk is largely on objects, but I integrate it with the other two things. Let's see if this works. No, of course not. Tech support. Thanks, let's try this. Ah, there we go. Got to be on the right thing. So my day job, I'm a Rubyist. Well, I'm supposed to be. I normally do a lot of JavaScript. I do a lot of front-end work. I'll get to that in a minute. I've been involved with PHP for, I don't know, a long time. But I started on PHP 4, so that will be making an appearance in my slides. I've mostly been focused on object-oriented programming since I started. I do a little bit with functional. Not that great at it yet, but I get the concepts. Online, I'm Machuga everywhere. So by all means, just address me as Machuga. That's fine. There's a lot of Matts, so I won't take any offense to it. In IRC, I'm always the guy who's going to ask you if you check the docs, and it's not always that polite, but when I'm patient, I'm that polite. I'm in there a lot. I'm not in there as much as it looks like because I do have a bouncer, but pretty much if you want to talk to me, just talk to me. I'm more than happy. So this is my wife, Hallie, and my daughter, Veda. And the reason I put this in my slide is because some people get a kick out of it. Her middle initial is I, so her initials are Vim. So if you know me, I'm a big Vim user. I work for a company named Think Through Learning. We go by Think Through Math because it's the name of the product. We make a platform that helps kids 3 through 12 learn math. That way they can do better in school, get into college, things like that. I'm the senior software developer. The title is really meaningless because all of the team is amazing and I have the best coworkers ever. And they put on conferences in Pittsburgh and do other amazing things in open source. So really happy to work there. Before I actually get into the talk, I just wanted to thank everyone because I really feel like we have one of the best communities out there. So, you know, by all means, give yourself a round of applause. Appreciate that. You're all super nice. We have screencasts, we have blog posts, we have like 9,000 articles. We have so many things out there, and I mean, that's amazing that people are willing to contribute that much because it's all free time. Like, we don't get paid for this. Taylor gets paid for this, but. All right, so objects, testing, and responsibilities. What? What do I mean? We'll start with objects. It's just object-oriented programming. Whether you want to think of it that way or whether you use some hybrid of procedural, object-oriented, functional, we're talking about objects. Object-oriented design does come into play. I'm going to mention a little bit on that, but I feel like Phil probably hammered in the design patterns pretty well. So I deleted all those from my talk. We're going to go over some pros and cons. Mostly the pros because I feel like if I'm just hitting or hating on objects the whole time, that doesn't really get a point across. And hopefully I can show you how it can improve your code. I'm assuming most of you are already using some form of object-oriented programming, right? Because we're using an object-oriented framework. But there's other ways you can kind of like next level yourself to using them properly. Because you know, you can put everything in your controller. You're not supposed to, but you can totally get away with it. And like I'm guilty of it myself. I used to do that all the time in the Code Igniter days, but it gets pretty unmanageable after a while. We're going to go over testing. I'm a huge proponent of testing. I do come from the Ruby community, and that's where I learned testing. So I'm like super big into it. And in PHP, things work a little bit differently. In Ruby, you can hack objects to pretty much do whatever you want. In PHP, it more so follows rigid rule set. So hopefully we can show you how to get around some of that. I think Jeffrey did a great job yesterday of demonstrating how you can get around PHP or work with it. Aspect mock will help you get around it, but I do want to try to talk you out of using it as your first choice. Nothing against the framework, I just want to show you the other options. Tests are good. Seriously, tests are good. There's a lot of hate in the community for tests. I don't think many of you hate them, you might, but it's not really well accepted in PHP. and I think it's getting better. I think the Symphony Core and Laravel and maybe Zen Framework 2, I'm not entirely sure, but there's a lot of frameworks out there that are putting in testing as almost a feature. Like you can actually confirm that the components work. And if you're using them as core components, that's like a crucial thing, right? You want to make sure that nothing breaks from 2.1.x to 2. Whatever, I don't know, some versioning number. Responsibility. This is also about accountability. You want to hold your components accountable for their actions. I find that arrays are a little anonymous most of the time. It's kind of hard to track down where they come from. Like, yeah, PHP normally gives you a location in the file, but when you're profiling and everything, it's a lot easier to see, like, this exception's being thrown from this class this many times, or I'm spending 80% of my time inside of the user model. It's pretty easy to debug that stuff, you know, within reasonable amounts. I want to talk about giving objects explicit responsibilities. There's a lot of talk with the single responsibility principle, and that's part of what I'm going to mention. That's a good concept. You don't have to follow it, but it does make your objects a little bit easier to test. It makes them easier to work with. But in general, you just want them to have a goal. Like, don't send them into what we call a God object, which handles everything. So you don't want your user object managing password resets, registration, adding their favorite band, or like something like that. Like, you can spread the stuff out. It's not going to hurt. You have a responsibility to your code. You want your code to be readable. You want your code to work. That's probably the big one. Your customers really like when stuff functions and makes them money. So you have a responsibility to your team. Who works with continuous integration right now? Or any sort of integration tests or automated test suites? Okay, it's a good number. When Jenkins fails, you normally have a way that it tells the entire team, and it will blame you. It says so-and-so broke the build. I think somebody said they have a Nerf gun in their office. Was that Dale? Dale has a Nerf gun that shoots him when he breaks the build. Some companies have a pink sombrero that they wear. Some have a hard hat. Like different things like that. And it's kind of funny, but at the same time, you don't want to be the one who broke the build. If it's the test, that's fine. If you broke production, that's a long weekend. So you do have a responsibility to your team. You don't want the team being sitting there like Sunday night working till 9 p.m. because you accidentally swapped out an object for something that's not compatible. Finally, you have a responsibility to your future self because in 6 months you're going to go look at your code and you're going to think, what the hell was I thinking? I do it for code that I wrote the week before. I don't drink, but sometimes I swear I was drunk when I wrote this stuff, and it just doesn't make sense. My slides on the plane were a great example of that. I don't know what happened, but nothing made sense anymore. All right, so objects. This is a quote from Alan Kay, who you can argue it if you want, but I call him the father of OOP. When he responded to someone's question about what object-oriented was, he said, I thought of objects being like biological cells and or individual computers on a network, only being able to communicate with messages. Smalltalk was a message passing language. Ruby is as well, and there's a couple more out there. Objective-C. The differences between invoking a function and calling a message or sending a message is kind of, like, we're not going to cover that, but at runtime, it's nearly the same thing. It originated from functional and procedural, and I was actually kind of shocked that it came from functional to a large degree. I actually learned that not too long ago, but it was a strategy for solving organizational issues and reusability. Object-oriented programming is also about data hiding. You don't need to care about everything that's going on, and it's way too much to keep anything in your head. Like, none of us know Laravel except for maybe Taylor, but I'm sure even he forgets things that are like buried deep in the core. We don't need to know that stuff. Like, we have facades to help us work with the parts that we care about. We use input get to get anything from put, post, get the query parameters. We can use the cookies super easily. Like, that's the kind of stuff I really appreciate. It's expressive. You can use it without remembering the whole system. It's just like a couple of methods that you use all the time, so it's great. It's easier to do testing if you have your objects broken out properly because you don't have to kind of sort through your object to get to a certain part. You don't have to mock 9,000 things. I'm sorry, I keep saying 9,000, but I saw Jeffrey do it yesterday. Or someone mentioned 9,000, now it's stuck. Like I put my URL as it's over 9,000. So, all right. So PHP's object-oriented history. There's a troll face here, and you'll probably see why. A lot of it's just me complaining, but who knows which version of PHP first got objects? You can yell it out. Anybody else? PHP 3. I like the 5.4 answer. we're going to get there. So PHP first got objects, and we're going to read this like a live action series, like we're going to run through how this happened. I feel like I should use an announcer voice like 16 years and 4 days ago, PHP got classes. So that's when it first came into the code base, and it's kind of cool that it's so close to this, but 16 years ago it made it in. PHP 3 got released in 1998. When it actually got in the code base, somebody mentioned that. And it was essentially a fancy associative array. So PHP 5.3 or 3 and 4 didn't really deviate too much. Like 4 got a little bit of extra ability, but I wasn't around in PHP 3 days, so I can tell you what PHP 4 had. We had classes, we had objects. The single inheritance was a little sketchy. I'll get to there when we get to the other part, but we had pass by value. So all objects were treated as a copy. If you came from C, everything was passed by value by default, so you had to pass a pointer or a reference. PHP was treated in the same way, and this is kind of an anti-pattern compared to every other dynamic language. And everything was public, so you could not say private, you could not say protected. If you see underscore function or underscore function name in any of the existing libraries, that was a convention that they used to say this is private. Unfortunately, it did stick around for a lot longer than I was hoping it would, but PHP has a lot of reserved words, so I kind of understand it. So PHP 5 to 5.2. We did get passed by reference, which is great. We got visibility, so we can now do private and protected. We got static methods and properties, class constants. The constructor was changed. It used to match C++, where you had to name it the same thing as the class. Now it's a unified one where you can just pass up the chain, it's fine, or if you change your class name, you don't have to change the invocation all the time. We got destructors, which aren't heavily used in PHP, but sometimes they're very useful. We got abstract and final classes. Little tangent, I don't like final because I can't override it. And yes, that's the point, but God, is it a pain in the ass. Interfaces. We now have type hinting. We have interfaces that do, sorry, type hinting's next, but we have interfaces that, they're like contracts. And we had them explained yesterday, but they allow us to say, you want these two functions on this class, and if you don't meet that requirement, it's not going to be usable. We'll get into that. So 5.3, we got usable single inheritance. We got late static binding. This was awesome. I will cover what late static binding is in a bit. We got namespaces, which is amazing. And we got closures. Closures aren't exactly object-oriented, but in PHP, they are actually objects. They're really fast objects, but they're objects. My complaints about 5.3, we got goto. What the hell? Who adds goto? No offense, somebody's going to watch that, and I'm going to get crap on Twitter. We also cannot import a full namespace. This is something I'm used to from other language, where you can say use illuminate, and then I don't have to mention illuminate anymore. I can just pull in all those furthering namespaces or classes. Why? Okay. 5.4 got traits and closure rebinding. The closure rebinding I'm not going to cover so much, but essentially this now works as you expect it, and you can actually link it to a different context. Who here knows what traits are? Okay, I'm going to introduce them. For those of you who did not raise your hands, have you used any language with mix-ins or modules of some sort? Okay. All right, we'll cover that. It took about 14 years, but we do have a very capable object system now, so that's great. We're going to cover the 4 pillars of object-oriented programming. And this is going to be repeat for a lot of you, but I just want everybody to be on the same field when I'm mentioning terms, glossary items. So abstraction. You remove and isolate some sort of related behavior or data. By the way, if anybody sees something they don't like or they have a question about what I'm mentioning at the time, just raise your hand. Someone's going to bring you the microphone, and when you get there, I'll address you. So, like, by all means, interrupt me. If you don't like what I'm saying, just say, I don't like this definition. Ben, don't do it. So an example of abstraction. If you used WordPress, this should look kind of familiar to you. It works a little bit differently, but you have like a getDB function, which will return you the current database connection. We have user show, fetch, does all the CRUD options mostly. And then we have user store data, which will just kind of use it. This works great. It's fine. You're passing around data a little superfluously, but what happens if you want a different database connection? You could add another database function, or you could change a constant somewhere. But what if you only want it for like one invocation? Like what if you have a multi-tenant application, you just need to send something over to another one? It gets to be pretty unmanageable. I mean, you can do it, but I don't like torturing myself, so we can abstract it. And I had a different example, but I figured like Eloquent is something we're familiar with, so let's look at it. Eloquent gives us the ability to find, delete, create, update, save. We have all that. It's all inside of a single object that we can just work against, with the exception of find is actually on the class. Encapsulation. It's pretty much like you want to treat it as if it's its own function. It's a black box. You say, give me this data, and it gives you that data. You say, change this data. It'll do it. You don't care how it's done. The cache store is a great example. You can have cache set somewhere in a config, and then you can give it to someone on your team and just say, cache this object for 5 minutes or whenever somebody changes it. They don't need to know if it's in Redis, MongoDB, database, memory. It doesn't matter. It just stores. You have a public interface. The visibility that I mentioned earlier with private, protected, usually you would use that to tell your users something. You want to tell your team, you want to tell future you want to say, don't touch these functions. These are for me. Use the public interface. That'll give you an easy time. It prevents leaky abstractions, so you're not like diving in, grabbing a property from an object that you have no business tampering with. You get what it wants to give you. Gonna give you, it's kind of an example, it's more of a bunch of stats. So last night I asked Taylor, which object has the most private and protected methods? So he pointed at the model object. So the properties on the model, we have 4 public, instance, and class properties. We have 19 protected and 0 private. I think that's a good ratio. We don't really need to be tampering with Eloquent's protected properties. Its methods, on the other hand, completely sway the other directions. We have 126 public and instant class methods. We have 25 protected and still 0 private. I can't remember if I explained it, but private just means you can't override it or overload it. And this is great because you're actually meant to use Eloquent. Like, you're supposed to interact with it. You want to tell it to do different things. You want to say, give me this relation, give me this object, save this object. You want to interact with it. You don't want to just say, hey, what's your database connection doing? What is, I don't have another example, I'm sorry. Inheritance. This is awesome, but it's a double-edged sword because it sometimes gets you. You can extend a class from another class. This is how Eloquent works and how controllers usually work, because you can inherit from the base controller. You get all the methods of the ancestry. If you say, I'm extending Illuminate model, you get everything that that extends from. So you pull in all those methods. You get all those properties. Sometimes that's great. Sometimes that's not what you want, and you're trying to take a shortcut, and you just don't want to write all that extra code. It's in those situations where it will eventually bite you. I can't tell you whether you should use it or not. It's often a good solution. Sometimes it's a very bad solution. I'll cover an alternative in a little bit. Just kind of tread very lightly on it. If you need everything that's on that inheritance tree, by all means, grab it. if you just need like one or two things, you can rewrite those. You can even abstract it out into another class and just pull it in. Okay. So here's an example. We have a rectangle. If you see most examples of inheritance, they're probably using a point or a line or a rectangle. So hopefully this looks familiar. Pass in the coordinates to a rectangle. We can say, if I get my mouse over there, we can say get coordinates, set coordinates, all that. Square has the exact same set. Diamond has the exact same set. That's fine, but it's a lot of code duplication. We could change one of those or accidentally change one of those, and then it just doesn't work, and we don't know why. If we use inheritance, we can just say that square and diamond inherit from rectangle. Now, if anything changes, they all behave the same way. Polymorphism. I think this is the best feature of object-oriented programming, pretty sure. It pretty much says that any object may be used as long as it implements what you're expecting. And this kind of ties in with interfaces where you say, I need this, this object to have this function. In this situation, you're just assuming it has the function. You can type in if you want, but it doesn't really matter. It's great because it allows code branching without an if-else statement. You've probably seen large switch statements that say, if type of user, do this. If type of guest user, do this. If type of logged in user, do action X. Polymorphism just says, here's a user, do X. You just work with the function that I give you, and you let that object be responsible for what it's supposed to do. PHP is a duck type language. If it walks like a duck is the normal phrase, you say, if it walks like a duck and it quacks like a duck, it's probably a duck. Type hinting is more like, you will be a duck and you will like it. You are guaranteeing that it acts like a duck. I don't really consider that duck typing. There's like a little feud on Twitter going over about that. As an example, Taylor, greet me in some way. Just greet me. He says, hey, Matt. Where's David? David, greet me in your native language. Hi. Yeah, killing me. Capel, greet me. There you go. So, aside from David, who I was trying to invoke a different response from, I asked him to greet me. I got different responses, didn't really care what I got. They all greeted me. I got some sort of answer. I was waiting for somebody to say what so I could use a throw an exception, but so that's essentially polymorphism. It's a big word, but it doesn't have to be scary. It's just like act on what I'm telling you to act on. Okay, so an example of this. If you've ever built some sort of widget library, this plays really well with this, all right? So you have a blog post widget, render. Gallery widget, render. Okay. So the page loader can just sit there and spin through them. It can say, this widget, render. In this case, I'm outputting to a string. I don't actually recommend doing that, but that's cool. If we use type hinting, it's the same thing. You give it an interface name widget. You say it's supposed to have render. Exact same code the rest of the way, except you add this little string, implements widget. It just guarantees that render has to be on that object. And then at that point, same code. So how is this usable? Phil and Fabian told you yesterday. I don't need to repeat that. I'm probably going to repeat some of it anyway. But design patterns, you can find common patterns in these things. Strategy pattern, decorator, presenter, those two are kind of close. Command pattern, whole bunch of them. The Gang of Four book has a lot of them. Phil already talked on that, I'm not going to cover it. But you can take advantage of all these object-oriented constructs and all the different techniques that you can use to work with them. So those are great. Code reuse and extensibility. This is why it was created. You're supposed to be able to reuse these objects. Java was kind of written with the write once, run anywhere. It kind of works like that. Object-oriented is almost the same way. You can normally use what you have somewhere else, but you normally have to tweak it a little bit. With inheritance, super easy. You can also compose the object with another one, and in general, that'll solve it for you. The Fluent class in Laravel 3 is a good example. You could add that to anything, and you could access, you can access an internal attributes array just like you would access attributes in Eloquent. It doesn't actually exist as a property on the object, but it'll act like it. It uses the magic getters and setters to handle that. Validations in Laravel, those are used all over the place. Sean has a form base model that you pull it in, use it inside that object, and it's its own it's a form object. You can use them inside controllers, which I recommend you normally do not do that. You can use them inside of a model. Sometimes it's useful, sometimes it's more of a pain because you have to work against it. An example, user registration versus a user updating their form. Bless you. Late static binding. So this is what I mentioned earlier. In PHP 5.2 and below, self didn't work like you would normally expect it in Python or Ruby. Let's see, I think I wrote it out on there. Self will call the class that the method was defined on. I'll show you an example of what I mean here, but static will call the method as if it's on the object you're working with. So we'll jump to the example to be a little clearer. If I have class A with sad face, it's going to return A object even if I call it on B. If I use happy face down there with static, it's going to give me B back. That's all it means. Okay, so traits. Since this one needed a little bit of explaining, traits allow for methods and properties to be placed pretty much into the ancestry of an object, just like inheritance would, but you're not inheriting from it, and you can't instantiate a trait. It's more like a collection of this data that you just say, the directive is use. So you would say, use my fancy trait, and you get all the methods and properties on that trait. It's compile time. In Ruby and other languages that support modules of some sort, you can get mixins, which are done at runtime. Kirk, where are you at? There he is. He wrote a DCI library that you can use, and it'll act like it's putting them on at runtime, which is kind of neat. It's great if you need to extend something. You can get away without it. It's fine, but just like one of those things I wanted to point out, you can't change these things at runtime. For those who don't know, PHP actually does compile before it runs. In a sense, it allows for multiple inheritance, and this makes a lot of people angry. It scares other people. It doesn't have to. It's not true multiple inheritance, and you can work around the weird stuff that it does. I think as developers, we work with something once, and it's a terrible experience, and we get really fearful that everything after is going to be the exact same way. I used C++ for 4 years, and multiple inheritance was a nightmare, so I totally get that, but if you work with it for a little bit and you see the useful parts of it and you use it very judiciously, if you use it in the right times, in the right place, it's a really helpful tool. If you abuse the crap out of it, like anything, it could go wrong. A lot of people were nervous about closures for a long time. And I think Laravel really helped show people that you don't have to be fearful of them. You can use them in a very, very responsible manner and get a really great interface out of it. JavaScript is a good example of how closures are helpful. Little caveat for anybody who doesn't use the closures too often in PHP, they're not really closures, like I mentioned, they're objects, but they have to have a scope passed to them. They can't wrap around their lexical scope like JavaScript can. So we have a use keyword on those, and that is not the same as the use keyword with traits. Just wanted to mention that because it's going to come up. It's great for abstraction. You can pull things out, you can use it. The example I like to use is categories or tags. Tags is a great one. You could have tags on listings, blog posts. You could tag a user. User could have multiple tags. You don't want to write that every time. And right now we have polymorphic relationships that we can do that with. Or if you don't have polymorphic relationships, you just have separate tables, you can just use categories. You can say, my trait is named categorizable. You use that. And then you set maybe a property. You say, my table is user tags or blog post tags. And it can take that in, use it, and then perform on that table just like you had the methods and properties on it all along. So here's a quick example. If we have trait bar which has a protected property BAS, and a public function BAS, just returns it. Man, Phil was right about me not using these keywords. I'm sorry. Foo and bar look great until you're presenting. So class foo uses bar. That means it gets all of these just like I put them on the class myself or inherited. So I can add the function set BAS, and it'll store it to that property. So if I use it just like this, it's just like I had it on the whole time or pulled from the inheritance tree. Just works. They're really nothing to be fearful of until you start stacking like 20 of these into one class. I don't recommend doing that. You can get away with it, but generally at that point, that's where you start running into collisions, and you have to start using the instead of directive to try to work around them. So if you have like 3 objects or 3 traits that use BAS, you have to tell it which one to use in what order. So how to get the most out of your objects? Tell, don't ask. This is a common term to just say you tell the objects what you want them to do. You don't go poking around in their internals hoping that you can kind of say, hey, what are you up to? Can I get at this property? Work with its public interface like it's intending for you to do. Don't start asking information that has no means being in your other object. A user object does not need to know about the store object except for maybe how to get there. Your object doesn't. That was a terrible example. I'm sorry, we're just going to skip that one. Composition over inheritance. So this one is kind of what I mentioned earlier. I don't want you to feel like this is a law. I don't want you to feel like this is even right. It's an option. Pretty much everything I'm saying is an option. Nothing in object-oriented is right all the time. It's right for your situation, and I can't tell you what's right at all. I mean, I can help you try to find an answer if you show me your code, but there's still going to be like 3 right ways to do it at least. So when you compose, you're throwing an object into another object. The goal is that the sum is greater than the parts. You want it to be a usable component. It provides flexibility because you can still use their own inheritance trees, but you can still take advantage of it not being the same class. Phil showed the decorator pattern yesterday. That's a good example. It takes more code to compose an object because you can't just say, I want all these methods from this inheritance tree. You can use traits to compose. Some people argue that it's not real composition, but I think it counts. You're composing it with a trait. So it's more work, but often you need that little bit of separation. You need to be able to be flexible with it. A good question to ask yourself is, does X belong in this object? Where X could be some sort of behavior. I mentioned God objects earlier. You don't want one object responsible for everything because then you have to test that object for everything. You have to debug it for everything. If it's broken out into separate little parts, you can test that easily. So I highly recommend doing that. Here I mentioned the composition with traits a little bit. It's kind of just a little bit of a coverage. I think it's everything I wrote earlier, but I just wanted to show it again. So now we're going to move into testing a little bit, and it's still about objects, but testing is the focus. So testing can be hard. It can be really, really hard. Depending on what you're testing, it can get very funky. Jeff mentioned mocks. Mocks are a great way to handle isolated testing. There's a few other options I'm going to cover a little bit later. So test-driven development serves many purposes. And before I start with this, don't feel like you have to do test-driven development. You can test after, you can test with writing a method. Just like I recommend having tests. You obviously don't have to, but I'm kind of a command line junkie. I don't really like touching the browser until I have to. So when I work with PHP, I'm in PHP unit, up until the moment I have to write something in the browser. So it can guide you to working with well-abstracted solutions. When you're trying to test in isolation, you really kind of get your butt kicked if you have a lot of dependencies in there. So if you're using new a lot, or if you're invoking static methods in any sort of way, it gets really tricky to get around that. And Jeffrey mentioned aspect mock. That can totally get around the weird stuff. And it's recommended for that, especially for legacy code bases. Legacy code bases, I would say start with an acceptance test every time because I'm sure you've all worked with them, all the MySQL underscore query or, you know, that kind of API. It gets really hard to test because it's all just global scope. They're useful to ensure your tests or your code works. That's a great feature. That is, you know, what you would expect. I'm testing it. It's automated. I'm just making sure that it actually functions the way I expect it to. It's also executable documentation for your code. For those of you who have seen the comments that blatantly lie to you, like the function body is clearly setting an object to act as a receiver, and somebody wrote, I don't know what this does, in the comment above it, or this comment gets the value of boo. No, it's setting something. This is a lie. It doesn't help you. It confuses you. It can add several minutes to your workflow of trying to figure out what that function is good for. If you have tests, you can actually ensure that it's telling you the right thing. That, of course, is assuming that your tests are right. And we'll get to how tests can lie to you in a few minutes. Running out of time. So I would always recommend that you start with some sort of acceptance criteria. Jeffrey mentioned you want to watch what names are getting thrown around, so this would count as like a big test. This is something that's an end-to-end run-through of whatever feature you're trying to test. So user registration, you can make a happy path acceptance test for that. So you would say, if everything goes right and it succeeds, I want to test for that. You normally need way more than one test for a path or through one feature because you have several paths that a user can take. What if a user gets halfway through, starts mistyping things? What if they skip fields? What if someone tries to cheat the CAPTCHA form? Different things like that. You need to run through the code. Normally one test is not all you need, but it's not that bad. We'll get into that. So the TDD cycle is red, green, refactor. Red is write a failing test, green is make it pass, and refactor is to clean it up. Also included in the third step is, it's sometimes called the fourth step, but you want to refactor your test too. You don't want to change the test to make your answer right, but sometimes the test isn't clear on your first run. You're just really trying to make it work. If you're using TDD, you just want to get it done in the shortest amount of time with the shortest amount of code. You're not going to make it perfect the first run through. That's fine. You can iterate on it. You can clean it up. You don't have to feel the pressure to get it completely right. It's just like any other code in your code base. Refactor it when you're ready. The full TDD cycle, as it was intended, you write an acceptance test, which is the outer unordered list here. And then inside that cycle, you iterate over it multiple times. You say, I'm going to create a unit test for all this. So I'm going to isolate my code. I'm going to test the certain components. And then when the whole thing is done, it'll be green. So you get the little greens, and then everything is good after. All right, so some teams differ on this viewpoint. You don't always need your integration tests passing or your acceptance tests passing to commit it. You never want unit tests failing because then everything's broken. You can't reuse any of it. With acceptance tests, some features don't need to work in every scenario to get it up to your staging server. So you want Jenkins to let it pass. You want it to go through. It's fine if it's red for a little bit. You don't want to leave it red in production. At least I wouldn't. Again, don't feel pressure to get everything done and perfect on the first go. This stuff takes a while. So what I mentioned earlier, base tests off acceptance criteria. The stakeholders have their features that they want. Can you raise your hand if you've heard of Cucumber or Behat? All right, so that's like human readable acceptance tests, right? Some companies have stakeholders who are at least tech savvy enough to read through this list of broken up English. Some even write it. Like I would love it if stakeholders wrote my test for me. That would be great. But they can say, as a user, when I'm doing this, I want this to happen. You can invoke that. You can. It turns it into regex, and it's like an invocable string. That might be Cucumber. But you can say, I'm going to base my test off this data. Then you can verify it with your unit tests. When everything's done, that feature is good to go. You can mark it off in Pivotal Tracker, and they can sign off on it. At that point, that feature's done. It's gone. You can iterate it and go to something else. Um, I mentioned here you want to guarantee your unit tests come together. Again, don't leave those red when you push it up. Otherwise, you're probably going to have a teammate knocking on your cubicle or pinging you on the internet going, what the hell? Like, I needed to use this code today. Um, by the way, don't feel bad the first time you've done that. I've totally done it because I checked it on like one version of PHP and not the other one. And I actually sent that up to GitHub and someone found that. So TDD is not the only way, like I mentioned. Tests don't need to drive or guide your code. I recommend that you try because it really helps you abstract. Like if something hurts when you're testing it, like if you feel like it's just sitting there socking you in the face, it's probably because you have too many things going on. I recommend that you listen to your tests. Like try to feel, like look for what it's making you feel. If you feel like you're scared to death of this code, it's probably too complex. Sometimes things need to be complex, but most of the time you can break it down into smaller chunks and make it easier to consume. So here's a little the tidbits on it. The tests let you know if something smells funny. A class that does too many things, hard to test. If it has too many dependencies, it can be really hard to test because you have to set up those dependencies. Or if you're actually calling new inside of the objects, then you have to have some way to mock those out, or you have to trust that they're not connecting to an external service. A test with too many mocks, that can be hard to maintain. You can use test doubles, which you're essentially using the same object that you would be using, but it's not doing the external services. It's not doing anything destructive. It's just there. And if a test gets too hard, it really does get abandoned. People just leave it green. They'll do anything they can to make it green and just let it rot in the code base. Some people just delete it. Don't be afraid to add more classes. Yeah, it's an extra file. You can optimize that. You can compile it. Laravel concatenates all your files together inside, well, its files and makes it faster to load. You can do the same thing. I don't know how to do it, but Taylor can tell you. So here's an example. This is the authority library that I manage with a couple of the guys in here. This is an example of how it calls this dispatcher. The dispatcher is just there, so if you want to listen for events, like if you want to log all the attempts on authorizable components of your system, you can have it log out to monologue or anything like that. So this is inside the authority object itself. You can set a dispatcher if you pass one in. You don't have to. And it'll try to set something on it. If the dispatcher doesn't exist, it just completely, it's a no-op. It doesn't matter. The dispatcher class itself has the fire directive, or the fire function, and it just runs that. It just calls the Laravel, or the illuminate event system, invokes this function. The actual behavior is not terribly important here. It's just I want to show you that I'm kind of setting it conditionally. It doesn't have to exist, so it's kind of like a flexible component. And I'm composing my authority object with the illuminate dispatcher, or any other dispatcher you want to throw in, really. So one of the unit tests on it, it just adds a listener for the event, and then it initializes authority, which will invoke that event on start. Afterwards, I assert that the test user has been changed inside of that closure, because I passed it in by reference. This is the one place in PHP you still have to pass something as a reference. Or I guess that's a standard object. So you just test it afterwards. And in here, oh, gotcha. In here you can see that I'm calling new. Your tests don't have to be perfect. I'm not perfect. I do stuff I'm not supposed to all the time. I'm careful about it. I make sure it's isolated. If you're doing things that are kind of like, this could get me into trouble later, just make sure you isolate it, like wrap it up. Third-party APIs can get you in a lot of trouble. Put something around it. Protect yourself. It also allows you to test the API without calling out to Amazon 50,000 times and blowing your rate limit. Some people try to test every method in your system. You do not need to do this. Like your private methods, they can stay private. Test the things that enact upon them. Test your public interface. Make sure that those private methods are returning the value that you want. You don't have to like test it to say, you know, like, I'm not even gonna give an example. Just don't test your private methods. Test the public interface. You sometimes need more than one test for a method. There's, like I mentioned earlier, there's paths through your code. You have to test the branches. You can't just say like, my calculator works and never test for division by 0. Somebody's going to do that. You know somebody's going to do that. Mocking can fall short sometimes, and it'll lose sync with your objects if you change them around. So if you, Jeffrey had a good example on that. If you change, if like you add a property that's a requirement, you have to make sure you account for that. If you don't test everything, try to test the areas that have high churn, the things that change often, because those are going to be the areas where you refactor and you want the code to be verifiable. Aspect mock is a tool. Please don't reach for it right away just because you're like, this kind of sucks. Like, you're probably fine. It's probably, a step or two away of being solved. You just have to like take a step back and breathe for a minute. Aspect mock is great for legacy, but normally dependency injection, or half the time it can just work in general. Just try to find the solution first because it helps your code get cleaned up a little bit. Like, you don't want to make your code look like legacy code on purpose. Finally, test your own code again, not the third-party code. You don't have to make sure that Eloquent works. Taylor does that for you. So when you're testing your models, test the functions that you add. Final things on testing here. This is not a good test. If you're checking a conditional and asserting true is true, and then asserting that false is true if it's failing, that's not telling anybody anything. That's kind of me looking at it and go, I guess the array is supposed to be empty, but either way it's asserting true. Or, it's not informative. This is also not a good test. Somebody wrote it to you in here and just asserted true. Does it work? I don't know. Like, this could be a pending test. I don't remember what PHP unit calls it, but in our spec we would call it a pending test. It's just, it'll mark it yellow. It says, I'm going to come back to this. Another one, if you're just repeating what the code is inside of your code base, that's not a test. You're essentially saying, did what I write actually, like, is it the right function, I guess? Like string reverse, if I just add the same function body, it's not what you want to test. Like, test string hello, and then just ensure that it's backwards. That's a good test. It lets the user know what they're looking for. So things like this actually exist. Like, this is contrived, but I've actually seen like just blatant lies in the comments. Like, what? So can it be cleaned up? Absolutely. But if it works, it works. So I got to fly through some of this because I'm out of time here. Responsibility. Like I mentioned earlier, you have a responsibility to not make tests like here. You have a responsibility to yourself. Give your objects a task. Hold them accountable for that task. Don't overwork your objects. Also, don't overwork yourselves. Test your objects, and things like this can help with the profiling, like I mentioned at the beginning of the talk. The responsibility to you. You have these responsibilities here. I already explained them. Just want to show them again. If anybody has any questions, by all means, I'd be more than happy to answer. Someone's coming over to you.
Is this working?
Mm-hmm.
Okay. So what I'm finding with my projects is using Packagist and Composer. If you're looking for a specific package, you kind of evaluate the package on a couple of things. You'll see how active it is, if the issues are solved quickly, if the original contributor is still involved. And one of the things I'll look for as well, if it's got a full test suite.
Right.
And so, as time's moving on, my projects are tending to be like fully unit tested before I've even done anything, because the whole of Laravel is tested and the packages which I use are all fully tested. And as that happens, I find my tests are becoming more functional and integration tests rather than unit tests.
Right.
Is that like, is that an experience which you're familiar with, or?
Yeah, do you act on those objects at all? Like, when say you have a library that you're pulling in and you're working with it, are you using that inside of your own objects or inside of some function invocation somewhere?
Yeah, possibly. I mean, it could be, maybe in one of my repositories or something along those lines. So,
Okay,
yeah,
so what I would say is you want to test it in there, but if it's making like a long time call, like a database call or anything that can be expensive, you'd want to mock that out in some way. You can absolutely still test it, but you don't want to test things that they've already tested. So like, if you're calling Eloquent, you don't want to test to make sure it's actually reaching the database. You know it's going to get there. You want to test to make sure some sort of action you're enacting upon it is actually doing its job. Like if you're running a map across it, you're changing all the values to, I don't know, like casting something to an integer by default. Like that's an action that you could test, but you don't want to test what the library is doing for you already. So sometimes it gets more functional and more integration-based tests, but a lot of times you can still test a low level and keep them fast. I guess that adds one more thing. If you're running the test suite, break your stuff into folders so you can execute the test suite on those folders so you don't have to run the integration tests every time. So I'm sure you've run them and you can tell they bog down over time and it gets a little disheartening.
and one more question. When I'm on RC, as Sean said, you're like always on there.
Yeah.
How do you get any work done? Because for
Uh,
me, it's like as soon as I'm on RC, that's the end of my work. There's no chance. But you like just hitting that RC all the time, man.
yeah. It's hard. So like I work from home and like I kind of get that time, like I get that flexibility. I don't have people coming over to my cubicle or anything. The most I have is my wife coming over or bringing the baby over and I'll play with her for a little bit. So I really don't have the water cooler experiment or experience anymore. So that's kind of like my time. That's when I'm socializing with people and I don't know, like I compulsively have to help people. Like I don't like when people are stumbling. I mean, if you see me in there, you know I don't give out answers. I force people to work for it a little bit. Like I will not write your code for you, and 99% of the time, unless it's like a really awesome problem, then I'll probably do it. But I want people to like learn how to help themselves. Like that's what I learned in college. It was how do I look things up on Google? How do I look things up on? For me, it was C++.com. You as a developer, you need to learn how to look things up, and you need to like learn how to solve them. And that's something I really want to teach everybody. And I mean, there's like back channel talk I do too, and it's like yeah, sometimes I have to shut it off. It looks like I'm there still because the bouncer's in the room, but like I mute everything. And the trolls have been keeping me busy lately, so that just makes me angry and I rage quit. Yeah. So I do get work done though. Mostly JavaScript. Okay. Anybody else?
Hi.
Hi.
Is this on? Yes. All right. So when would you use a trait over an abstract class or especially interfaces?
Interfaces. So I can still define an interface and use a trait. It's when I when I don't want to write the extra code. If I know all the things match up except for one property, I'll absolutely use the trait. If I need to change a lot, I normally won't use the trait. And if I just need to make sure that they have the same functions but they do completely different things, I would just use an interface. To be truthful, I don't use interfaces much because like I do a lot of Ruby and I do a lot of JavaScript and we don't have explicit contracts. So I just assume that whatever object I'm using is being responsible, which can be dangerous, but most of the time it's people at work doing it, so I know they're going to use it right. So like in the situations you would use inheritance, but you already have an ancestry that you don't want to break up, you would use the trait to inject those methods. That would be a good use case. I don't know. I like traits, so some people just don't like dealing with it. Anyone else? Okay. Part nervous about this.
Not really a question so much, but I just want to kind of work off the previous question as well. I find generally speaking that traits are really good for really basic implementations, just some really basic functionality. I went through a phase of using traits for just about everything, which is a really good way of finding the limitations of traits, and found that they're useless a lot of the time. If you're doing anything more than kind of a couple of methods, whatever, they tend to get in your way.
That's why I think tags are a great example. They're almost the same thing every time.
I have a question.
Yeah.
I'm like a new developer, like green, like I wouldn't even say noob, like maybe like fetus level. That's how new I am. And so here's my question to you. When you're learning, you're really just wanting to get in there and build with the language. But like from you and from Jeff, you guys have done a fantastic job of making this seem something that's like, I can actually reach testing. Like it all, because of all the terminology, you know, unit test, whatever test. So I get it. I get why it's important. But here's what I struggle with. You want to build something. You want to create something. And I'm sure you might even struggle with this. You want something new and you have this idea. Do you just put on the brakes and start writing tests? I can see where you might use the test as like, especially when you mention pending, almost as like a to-do list. And I get that, but like, do you ever get halfway into it and say, oh God, now I gotta go back and write tests? I think that's why I know I get a little anxious about testing, is that you have to either start from fresh or I'll just forget it and just keep writing. So
Right.
do you have any advice there or recommendation?
Don't feel guilty about spiking something out. Like, never feel guilty about it. If you have an idea and you know tests are going to like break up your thought pattern, by all means, just crunch through it. The great thing about Git is you can revert it. Like, you can pull all your changes back or switch to a different branch, and you have all those changes if you need to reference them. But you can start over, like writing it in a very object-oriented way with the tests. I spike stuff out all the time. Like, I have sometimes an embarrassing amount of spikes because I'm like, nah, I don't like that. Go back, delete it, do it again. And when I'm happy with it, I just set it off to the side, set a new branch, and then I'll continue working in a very object-oriented way. So then I'll write my test first just to make sure I didn't do something silly, or a lot of times like I'll forget an acceptance criteria if I spike it out. So I have to like write those first and then just make sure I didn't skip over it. So, you know, like if you have a very small feature that's just like some flag has to be set every time a user clicks a button, you need to make sure that actually gets done instead of like, oh, I just implemented the JavaScript and I forgot the PHP, you know. So things like that. But yeah, never feel guilty about spiking out a feature. Absolutely.
Is spiking out something I should learn and say, and people will think I'm cool if I say it?
Yeah, you'll get hipster points, but you have to drink Starbucks when you say it. Spike it out. Yeah, no, spiking is
Thank
just,
you.
you know, quick iteration, cowboy code it. That's what Jeffrey called it. Same thing. You also need a Volkswagen belt buckle. That'll totally get you scene points. Okay. All right. Thank you. There we go.